Okay, so I wanted to show off our new KiCAD plugin, which generates test point reports compatible with what the Jigs app needs for accurately generating your bed of nails test fixtures, test jigs. We've got a write-up on what a test point report is, what it needs, and what fields we use. Bare bones is just the XY position and the net that the test pad is attached to. We've got a write-up on how to generate these in different tools if you're not using KiCAD, even though this plugin is specifically for KiCAD. And we've got some advanced options and sort of what fields you need to include and what extra checking we can do if you include extra data. So this is all available on a website up here at the docs. This is the GitHub page for the KiCAD Test Points plugin. It's an action plugin, and all of the releases are here. We've got some docs, some examples, some pictures. So to demonstrate how this works, we're going to be showing off the Glasgow, which it's an exciting tool. We're really looking forward to getting ours. It's been delayed for a while. I'm not actually really sure why, but it's finally out there. It's on Crowd Supply. It's very exciting. It looks like a nice little piece of kit for embedded development. So it's an open source project, and it's available on GitHub with all the design files. So that's what we're going to do. We're going to use this plugin on the Glasgow board. All right, so this plugin works by setting the fabrication property of the pad that you want to probe. Got a few options, and you choose test point pad. Here, these are actual test point footprints. So one thing that you might want to do is actually edit the library footprint so that this pad is permanently set to have that fabrication property. So it's the same thing. You set the fabrication property in the library, and then every time that you update the pad, every time you update the footprint, it will set the fabrication property being a test point. Alternatively, if you don't set that, every time you update it and select everything. So if we do, so this is the pad that we just set the fabrication property for, test point. And if we select the footprint, update footprint from the library, and we select everything, then this will reset the fabrication properties. So it's set back to none because that's what it's set to in the library. So set it to a test point. We've already done that with a bunch of other points, both here on the top where they've got some test points, and on a bunch of the through-hole components and the test points on the back of the board. So these are all set to be test points because that's how we're instrumenting this. So there's our plugin test point report. It's available on the in the PCM, the plugin and content manager in KiCAD. Right now it's in pre-release, so it's in a different repo. But here it is. You'll be able to download that just from the regular KiCAD official repository sometime very soon. Here's all our metadata. We already have it installed, but you just hit install there. Discard pending changes because we want to use it. So we already have all of our test points selected. I'm just going to run the test point reporter. Browse. It defaults to the directory with the board that we're currently working on. Default name. All right. Sure. All right. So now our test point report has showed up in in our project manager. Going to open it up in LibreOffice, which is another great open source project, by the way. Okay. And that's it. These are all of the fields that we need. We've got the reference designator of the footprint, the pad number, the net it's attached to, the net class of the corresponding net on the design under test, what side the pad is on, which is particularly important for surface mounts. So this is only accessible from the top side of the board. We've got the X and Y position and pad type, through hole or surface mount, and then what side the footprint is on. So the footprint side is useful for particularly when you're doing through hole parts, and usually you want to access a through hole part from the opposite side. So if you have a pin header, you want to be putting your ATE probe on the bottom of the solder blob. So this is all you need. That's how easy it is. Again, you run the report, same file as before, submit. It's right there. Here we go. Now, if as we discuss in our documents, KiCAD is the first one, the first feature that I know that has given KiCAD a test point reporter. All of these tools, so Protus, Pulsonics, Pads, Cadence, Altium, Allegra, OrCAD, CADStar, Target 3001, Easy EDA, they all have a GUI-based test point reporter, as DipTrace, Eagle / Fusion 360, and KiCAD were the only ones that didn't. So we're pretty jazzed about this plugin. We do have another way of generating the test pad report, which is my preferred method. It's this other Git repo. We have it available here. It's a command line tool, and it can also be used with the output from this test report. So if you generate this test report and you want to make sure that all of your that these pads of these footprints are always being probed, you can feed this test report into the command line tool. So even if you have updated the pads and they've cleared their fabrication property, something like that, heaven forbid, you can still get all of that back. And that's our preferred method, because it's an easy way of doing an automated generation thing. So we like to have it as GitHub Actions or GitLab or whatever, so that we generate all of our test pad reports when we do a commit. That is in the command line, so it's a little bit more set up, whereas this plugin, it's right there, it's all in the GUI, it's super simple. So yeah, hope that's helpful. If you have any questions about the plugin or test point reports or your project, reach out to us at thejigsap.com. We'd love to hear about your project. Love to hear what you're working on.